Hello, and welcome to our 2014 update. It's been a very interesting year with a lot of interesting discoveries. One of the most fascinating was the fact that we landed a spaceship on a comet in 2014. We didn't cover comets in our segment on the solar system, so we'll cover them now to put that landing into perspective. We also have two continuing stories. One is the G2 cloud that was discovered, heading towards the black hole at the center of our galaxy. Well, it has survived its passage, which simply is not possible for a gas cloud. So we'll go into that. The other story is Gaia. In the 2013 update, we talked about the launch of Gaia that's going to map 1 billion stars in the galaxy and really get us a very good feel for how far away they are. It's now in operation. I'll show you what the Cat's Eye Nebula looks like to Gaia. Then we'll cover some of the spectacular pictures taken by Hubble in the past year. In the Milky Way, we'll take a look at the Monkey Head Nebula, a couple of other beautiful sights. In particular, there's a star system with brand new stars that haven't quite yet begun to shine with fusion light. And so we'll take a look at that, XZ Tauri. We'll also take a look at globular clusters, globular star clusters. There was a theory about how they developed. Well, taking a look at globular clusters in a nearby galaxy showed that that theory could not be correct. We also have news about ultra-compact galaxies, black holes, supernova, unexpectedly large halo in a particular galaxy, and a new look at the ultra-deep field. But first, we'll cover comets. In our segment on the solar system, we showed comet Shoemaker-Levy 9 colliding with Jupiter in 1994. It left a hole the entire Earth could fit into. But we didn't cover comets themselves, so we will now. A comet is a small solar system object made of a mixture of frozen water, ammonia, and various hydrocarbons, such as methane. When passing close to the Sun, it heats up and begins to outgas, displaying a visible atmosphere or coma, and sometimes a tail, the coma pushed back by the solar wind. You can see the jets in this close-up photo of Comet Hartley 2. Comet nuclei range from 100 meters to tens of kilometers across. The coma and tail are much larger, and if sufficiently bright, may be seen from Earth without a telescope, like this image of Comet Ison, or Ison. From ancient Greece to the middle of the 16th century, comets were thought to be luminous vapors in the Earth's atmosphere. Here's a tapestry that illustrates the 1066 comet. Here's the Great Comet of 1577, as seen over Prague. Tycho Brahe studied this very bright comet that shone in the night sky for 74 days. He found that he could not see any parallax. From his data, he concluded that the comet must be at least 6 times further away from the Earth than the Moon. This took it out of the Earth's atmosphere and started people thinking differently about comets and planets. Remember that the Ptolemy model had rotating spheres holding each planet in place. Tycho's findings would have comets crashing through these crystal spheres. As you can imagine, this tipped the scales in favor of the Copernican sun-centric model and left open the question about just what holds the comets up. Using the Great Comet of 1680, Edmund Halley worked with Isaac Newton to find out if comets were subject to the same forces as Newton had proposed for the planets. The data showed that the long elliptical paths of the comets fit Newton's theory of gravity perfectly. In 1705,
Halley studied the recorded path of the comets of 1531, 1607, and 1682. He proposed that they were all reappearances of the same comet, and that it would be back again in 1758. It was. This was a spectacular vindication of his bold conjecture and of Newton's gravitational theory. For his success, the comet was named after him, Halley's Comet. I saw it in 1986. Its orbit goes out past Pluto, so it won't be back again until 2061. Comets come at us from all directions, and we have seen that they have two kinds of orbits, long and short. Long-period comets can take thousands of years and have unpredictable orbits. Short-period comets take as few as 3 years and as long as 200 years. They are also much more predictable. These two kinds of orbits led to the idea that comets originate from two different places. We have seen that the short-period comets originate in the Kuiper belt. This is a volume of space similar to the asteroid belt, but much further away and much larger. The Kuiper belt is between 30 to 50 astronomical units away from the Sun. It is estimated that the Kuiper belt contains 100 million comets. Long-period orbits indicate that these comets came from a reservoir much further out than the Kuiper belt. The Dutch astronomer Jan Oort proposed the existence of a cloud of comets between 5,000 and 50,000 astronomical units from the Sun. Other estimates have it going out much further. All estimates put the Oort cloud well outside the heliosphere. Jan Oort estimated that this reservoir contains 100 billion comets. No space probe has yet been sent to the area of the Oort cloud, so its existence will remain a mystery for some time to come. Now, the biggest news for the solar system this past year was the actual landing of a probe on a comet. 67P hails from the Kuiper belt. It has a 6.5-year orbit around the Sun. It will make its closest approach to the Sun on August 13, 2015. The European Space Agency launched the spacecraft Rosetta in 2004. Its mission was to rendezvous with Comet 67P, deploy a lander called Philae to its surface, and escort the comet as it orbits the Sun. 10 years later, on August 6, 2014, after getting several gravity assist velocity boosts and traveling 6.4 billion kilometers, Rosetta rendezvoused with 67P. Philae landed on the surface on November 12th, becoming the first spacecraft to land on a comet. Here we see the lander's big bounce off the comet, with these pictures captured by its orbiting mothership. This is where it first landed. You can see the before and after pictures, where Philae made its mark. But the harpoons that were meant to anchor it to the comet did not deploy. It ended in the shade and has lost its power. And although we have lost touch with the lander, we will continue to receive data from Rosetta as 67P orbits the Sun. Here's a couple of other comets that graced our skies in 2014. Here's Comet Lovejoy. On January 7th, it will be about 70 million kilometers from Earth. Lovejoy is an Oort cloud comet. The next time Lovejoy returns will be around 10,015. This composite Hubble telescope image captures the October 19, 2014 positions of comet sighting Spring and Mars in a never-before-seen close passage of a comet by the red planet. On that date, the comet passed by Mars at approximately 1/3 the distance between the Earth and the Moon. Sighting Spring is headed back to the Oort cloud, and won't be back for 1,000,000 years. Before we get to some of the new and spectacular Hubble pictures, I'd like to update you on 2 continuing stories. One is about the G2 gas cloud, and the other one is an update on the Gaia mission that began in 2013. You may remember, back in 2011, astronomers said they'd discovered a cloud of gas called G2, accelerating towards the supermassive black hole at the center of the Milky Way. It was thought at first the cloud would meet a fiery end as it passed into the Milky Way's black hole as early as 2013. It did not. G2 was completely unaffected by the black hole. There were no fireworks. This image from the Keck Observatory shows that G2 survived the closest approach to the black hole. In November 2014, UCLA astronomers offered a new explanation as to what G2 is and how it survived its black hole passage. They now suggest that G2 is a pair of binary stars that had been orbiting the black hole in tandem and merged together into an extremely large star. As we noted in our last update, Gaia was launched on December 19, 2013. It is now 1.5 million kilometers away, orbiting the L2 Lagrange point. From this vantage point, Gaia will scan the sky continuously for the next 5 years, charting 1 billion stars in the Milky Way. The scientists at the European Space Agency use the familiar Cat's Eye Nebula in conjunction with the Hubble Space Telescope as part of a fine-tuning exercise. This first image shows a Hubble exposure of the Cat's Eye Nebula. Gaia's onboard detection algorithm registered more than 84,000 detections inside the nebula. In this second image, we see what Gaia saw. And here we see the combined image. Analysts were somewhat surprised by how well Gaia's detectors actually traced out gaseous filaments in the nebula. Various details in the structure of the nebula, as well as the unexplained presence of hard X-rays, suggests that the central star may be a double star system with an accretion disk and precessing jets. Gaia will carefully monitor this object until 2019 and may well reveal the binary nature of this system. Here's a striking view of a multiple star system called XZ Tauri, its neighbor HL Tauri, and several nearby young stellar objects. Embedded within a rust-colored cloud lies XZ Tauri. XZ Tauri is blowing a hot bubble of gas into the surrounding space, which is filled with bright and beautiful clumps that are emitting strong winds and jets. These objects illuminate the region, creating a truly dramatic scene. Above and to the right of XZ Tauri, an equally epic scene is unfolding. Wisps of deep red seem to be streaking away from the blue-tinged clumps on the right. This bright blue patch contains a star known as HL Tauri. XZ Tauri and HL Tauri are textbook examples of a class of star known as T Tauris, young and rapidly rotating with strong magnetic fields and powerful winds. They have yet to reach the temperatures necessary for hydrogen fusion deep in their cores. It will take another 100 million years for these stars to trigger these reactions and evolve into a fully fledged star like the Sun. To celebrate its 24th year in orbit, the Hubble Space Telescope has released a beautiful new image of the Monkey Head Nebula. This colorful H2 region is filled with young stars embedded with bright wisps of cosmic gas and dust. The icing on the cosmic birthday cake takes the form of young white and pink stars sprinkled among the glowing clouds pushing away the dark stellar nurseries in which they are formed. This new Hubble image is the best ever view of the Tarantula Nebula in the Large Magellanic Cloud. Visible in the upper left of center is a sparkling star cluster known as R136. It was initially identified as a star, but astronomers were puzzled over how one single monstrous star could illuminate such a giant H2 region. However, astronomers later realized it was actually a cluster of stars. Here we see the view as seen via the infrared camera. Notice how the cloud cover dissolves to reveal stars we couldn't see with the optical spectrum. New Hubble observations of globular clusters in the dwarf galaxy Fornax show that they are very similar to those found in the Milky Way. But the current theories on how these clusters formed predicts that globular clusters should only be found nested among large quantities of old stars. Astronomers used Hubble to observe 4 Fornax globular clusters. Detailed observations of the 4 clusters show that they also contain a star mix similar to clusters in the Milky Way. But unlike the Milky Way, the galaxy that hosts these clusters doesn't have enough old stars. This finding means that the leading theory on how these mixed generation globular clusters formed cannot be correct. So astronomers now need a new theory to account for the existence of these mysterious objects in the Milky Way and further afield.
There are many different types of supernova in the universe. Some supernovae are thought to have exploded from a single star. Other supernovae are thought to arise in a binary system consisting of a normal star and a white dwarf companion. SN 1993J is a Type 2b supernova. It's unique in that its light spectrum shows that the exploding star had no hydrogen. For that to be the case, a binary system is required to lose the majority of the primary star's hydrogen envelope prior to the explosion. Astronomers, using NASA's Hubble Space Telescope, have discovered this supernova's companion star, confirming this leading model for Type 2b supernova. This is a composite image of supernova SN 2014J in the galaxy M82. It is a Type 1a supernova, the kind we use as a standard candle rung in our cosmic distance ladder. At a distance of approximately 11.5 million light-years from Earth, it is the closest supernova of its type discovered in the past few decades. Astronomers, using a ground-based telescope, discovered the explosion on January 21, 2014. This Hubble photograph was taken on January 31st, as the supernova approached its peak brightness. Here's a look at a pair of galaxies. NGC 4647 is the spiral galaxy in the upper right. M60 is the huge elliptical galaxy. On the edge of M60, there is an ultra-compact galaxy known as M60 UCD1. New Hubble observations have found a supermassive black hole with a mass of 20 million suns at its center. M60 UCD1 is a tiny galaxy with a diameter of only 300 light-years, containing some 140 million stars. This is 500 times smaller than the Milky Way, but its supermassive black hole is 5 times more massive than ours. This shows just how significant this black hole is, and it leaves open the question about just how a black hole this large could have been created in the first place, given the small number of stars in its galaxy. Here's a simulation that shows how the small, dense galaxy may have been formed. One theory is that it formed at a time when the galaxy was much, much larger. But in a collision with M60, after the black hole had formed, it lost most of its stars to the larger galaxy. In any case, the existence of black holes in ultra-compact galaxies leads one to speculate that there could be many more supermassive black holes in the universe than first thought. By the way, Messier 60 also has its own supermassive black hole with a mass of an amazing 4.5 billion suns. NGC 5548 is a well-studied Seyfert galaxy with a bright, active nucleus. This activity is caused by matter flowing into the 65 million solar mass supermassive black hole at the core. The disk is heated so much that it emits X-rays near to the black hole, and less energetic ultraviolet radiation further out. The ultraviolet radiation can create persistent winds strong enough to blow gas away from the black hole. NGC 5548's persistent wind, which has been known about for 2 decades, reaches velocities exceeding 3.5 million kilometers per hour. But a new wind has arisen, which is much stronger and faster than the persistent wind. The new wind reaches speeds of up to 18 million kilometers per hour, but is much closer to the nucleus. This activity could provide insights into how supermassive black holes interact with their host galaxies. You'll recall that we covered Centaurus A in our segment on the local volume. We saw its amazing jets. Now Hubble has probed the extreme outskirts of this stunning elliptical galaxy. The galaxy's halo of stars has been found to extend much further from the galaxy's center than expected. Along the galaxy's length, the astronomers probed a region some 450,000 light-years across. For the width, they explored along 295,000 light-years. This is ESO 137-001, a part of the Norma Galaxy Cluster near the Great Accelerator. The image not only captures the galaxy and its backdrop in stunning detail, but also includes intense blue streaks streaming outwards from the galaxy, seen shining brightly in ultraviolet light. These streaks are actually hot young stars encased in wispy streams of gas that are being torn away from the galaxy by its surroundings as it moves through the Norma cluster. This violent galactic star extraction is due to a process known as ram pressure stripping, a drag force felt by an object moving through a fluid. The fluid in question here is superheated gas that exists at the center of galaxy clusters. This image of Able 2744 is the first to come from Hubble's Frontier Fields observing program, which is using the magnifying power of enormous galaxy clusters to peer deep into the distant universe. A mix of hazy elliptical galaxies and colorful spirals can be seen clumping together in the center of this image. The effects of the cluster's gravity can be seen in the blue arcs and distorted images that are scattered across the frame, including galaxies that seem to be bleeding into the surrounding space. The arcs are actually the distorted images of galaxies far in the distance. As well as creating weird shapes, lensing also magnifies the images so that astronomers can see more detail. This means that distant objects that otherwise would be too distant and faint to be seen become visible. At the center of this image lie two elliptical galaxies that have strayed into each other's paths. While this region has been observed before, this new Hubble picture shows clearly, for the first time, that the pair are two separate objects. However, they will not be able to hold on to their separate identities much longer, as they are in the process of merging into one. The stellar infants, thought to be a result of the merger, are part of what is known as beads on a string star formation. This type of formation appears as a knotted rope of gaseous filaments with bright patches of new stars, and the process stems from the same fundamental physics which causes rain to fall in droplets rather than as a continuous column. 19 compact clumps of stars make up the length of this string, woven together with narrow filaments of hydrogen gas. The star formation spans 100,000 light years. The patch of sky in this image has been previously studied by astronomers in a series of visible and near-infrared exposures taken from 2004 to 2009. That's the Hubble ultra-deep field we covered in our segment on the cosmos. Now, with the addition of ultraviolet light, they have combined the full range of color available to Hubble, stretching all the way from ultraviolet to near-infrared. The resulting image, made from 841 orbits of telescope viewing time, contains approximately 10,000 galaxies, extending back to within a few 100 million years of the Big Bang. This is the most comprehensive picture ever assembled of the evolving universe. The study is called the ultraviolet coverage of the Hubble ultra-deep field. After finding the Higgs boson last year, the European Centre for Nuclear Research, CERN, shut down for an upgrade. It will reopen in 2015 and begin a serious search for dark matter. Their website is packed with great learning projects. One is on antimatter. The teaching materials available here will allow teachers to introduce topics in modern physics to middle and high school students, and to do so in interesting and novel ways. It includes a series of lesson plans, background materials, presentations, recorded lectures, movies, animations, games, posters, photos, and ideas for practical activities in the classroom. All this material is available for free when used for educational purposes. As we did with the video book itself, here are the links to the Hubble and other locations where I found the information contained in this 2014 update. These are the places where you can go to find out more information. And don't forget, every How Far Away Is It video segment, including this one, has a document with the text, pictures, and notes, located on the howfarawayisit.com/documents website. Thank you for watching.